Hey, my name is Bruno Motutu, and this is one of my videos for ALP2. The SLO covered in this video is SLO4, which says solve trigonometric equations algebraically, determining all possible solutions and all solutions on a given interval. Here I give out some tips for solving trigonometric equations algebraically. We know we are going to use our algebraic techniques like factoring, collecting like terms, and we'll need our knowledge on the unit circle and finding reference angles. And the most important thing is to isolate the trigonometric function in the equation. This is very necessary. Now let's try on these examples. They say solve the following trig equations determining possible solutions and solutions on given intervals. So we're going to find the possible solutions, that is the general solutions, and the solutions on given intervals. Let's start with number 1. The first one says root 2 sine x is equals to 1 on 0 to pi. So this is where you have to isolate sine x. So we divide both sides by root 2, so it's going to give us sine x is equals to 1 divided by root 2, because the root 2 on the left side cancels, and x is going to be equal to sine inverse of 1 over root 2. If you want, you could rationalize it. It gives us root 2 on 2. So this x is equal to pi on 4 and 3 pi on 4. These are the solutions on the interval 0 pi, and the general solution for this is going to be pi on 4 plus 2 pi n, and or 3 pi on 4 plus 2 pi n. Here it says root 3 tan x minus 2 root 3 equals to negative 3 root 2. And it doesn't give an interval, so we're just looking for the general solution. So root 3, we isolate 10, root 3 tan x is going to be equals to negative 3 root 3 plus 2 root 3. We added 2 root 3 on both sides to cancel the 2 root 3 on the left hand side, and root 3 tan x is going to be equals to root 3 negative root 3, and when we divide both sides by root 3, tan x is going to be equal to negative 1, so x is going to be equals to 7 pi on 4 plus pi n. We're given 6 sine 5 theta equals to negative 3. So we are going to divide both sides by 6 to isolate sine. So we're going to have sine 5 theta is equals to negative 3 on 6. Sine 5 theta is going to be equals to negative half, and 5 theta is equals to sine inverse of half, or work in radians like I prefer. So our answers are 5 theta equals to 7 pi on 6, negative 7 pi on 6 plus 2 pi n, or 11 pi on 6 plus 2 pi n. But that's for 5 theta, so if we want to find theta, we have to divide all through by 5. So, and if we're dividing each, it means multiplying by 1 on 5 across. So it's going to be 7 pi on 30 plus 2 pi n on 5, or sorry about that, I'm a perfectionist. or 11 pi on 30 plus 2 pi n on 5. And that's the general solutions. 3 cos 4 theta plus 4 equals to 5. Now we're going to subtract 4 from both sides, and we're going to have 3 cos 4 theta equals to 1. And after this, we're going to divide both sides by 3 to cancel the 3 on the left hand side, and we're going to have cos 4 theta equals to 1/3. Now we take the arctan on both sides. 4 theta. Let me wipe this. I don't know what I was writing. 4 theta is equals to the cos inverse of 1/3. We're going to work in radians. And so 4 theta is equals to 1.2310. Now for the general solution for this is 1.2310 plus 2 pi n. That's one solution, and now we have to find the second one. We're going to subtract 1.23 from 2 pi, and when we subtract that from 2 pi, we're going to have 5. Let me write it down. 2 pi is equals to 6.2831185 minus 1.2310. We're going to have 4 decimal places 5.0521. So the second solution is 4 theta equals to 5.0521 plus 2 pi n. Now we are going to divide by 4 in the both equations. So the first one is going to give theta equals to 0.3078 plus pi n on 2, and the second one is going to give theta, when you divide by 4, theta equals to 1.2630 plus pi n on 2. Now we have the ln of a function equals to 0, and from our natural logarithm class, we know that ln of x, when ln of x is equals to 0, that means x is equals to 1. So from this equation, we know 2 minus sine squared x is going to be equals to 1. When we subtract 1 on both sides, we're going to have 1 minus sine squared x equals to 0. And this is a perfect square, so we're going to have 1 minus sine x, 1 plus sine x equals to 0. We make sine the subject, so sine x is going to be equals to 1, or sine x is going to be equals to -1. So sine is 1 at 90. So x is going to be equals to 90 degrees, or x is going to be equals to 270 degrees. Now this is the answer on this interval. General solution is going to be 90 degrees plus plus 360 degrees n, or x equals to 270 degrees plus 360 degrees n.